Here in today's session we are going to work out a problem from exercise 1.3. A graph representing the function f of x is given in the figure. It is clear that f of 9 is equal to 2. So similarly we are asked to find f of 0. So f of 0 is 9. You can see it from the graph, and f of 7 is equal to f of 7 is 6, and f of 2 is also 6, and f of 10 is 0. So 0 here, 0 is the value in the x-axis. The corresponding y-axis element is 9. The x-axis element is 7 and the corresponding y-axis element is 6. The x-axis element is 2 and the corresponding y-axis element is 6. The x-axis element is 10 and the corresponding y-axis element is 0. So now the second question asked here is find x. For what value of x is f of x is equal to 1? So x is equal to, when you look into the graph, you will find x is equal to 9.5 for f of x is equal to 1. So it is between 9 and 10. So it cuts the x-axis between 9 and 10. So it will become 9.5. The third one is describe the following domain and codomain. So domain is values of x, as I have said already. So x is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So it can be also described as x such that x lying between 0 and 10 for x belongs to R. So then the range, they have asked for the range. So range here is also from 0 to 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So here descriptive form for this is x such that x lies between 0 to 9 for all values of x belonging to R. So this is how you have to read it. Then the last part of it is what is the image of 6 under f. So image of 6. The image of 6 under f is 5. So you can look into the graph, you find image of 6 is 5. So the second problem for today's session here is an open box is to be made from a square. An open box is to be made from a square piece of material 24 centimeter on a side by cutting equal squares from the corners and turning up the sides as shown in the figure. So here these squares are cut out of this bigger square to make it an open box. Express the volume V of the box as a function of x. So this is the question, and here we know that volume of a box is equal to cuboid, volume of a cuboid. So length into breadth into height. So here what are the values of L? So 24 minus 2x. Here look here, the entire length of this bigger square is 24, is given to be 24. So we are cutting out x this side and the x this side. So this the smaller square will be of length 24 minus 2x. Why 2x? Here 1x and the other x here. So 2x minus 2x. So this will also be 24 minus 2x. So breadth is also 24 minus 2x. And this part is folded upwards to make the height of the box. So h is equal to x. So volume of the box is equal to L into B into H. So L is 24 minus 2x into breadth is 24 minus 2x again, and H is x. So the product will be 576 minus 48x minus 48x plus 4x squared into x. So the x is outside. First we are bringing out the product of this. So here the final answer will be 4x cube minus 96x squared plus 576x. So this is the expression of volume of the box as a function of x. Thank you.